For most of human history, the night sky wasn't just a beautiful view. It was the only map, clock, and calendar we had. To our ancestors, the heavens were a giant, glowing code. A puzzle waiting to be solved by the patient and the brave. Humans began to see patterns in the chaos. Hunters, animals, and gods were traced in the cold light of the stars. These patterns told them when the seasons would change, crucial data for the first farmers to know when to plant and when to store. By 3,000 years ago, in the fertile plains of Mesopotamia, the Babylonians turned this observation into a rigorous science. Their priests were the world's first true data analysts. They recorded every movement of the planets on tablets of clay. They discovered the Saros cycle, an 18-year repeating pattern that allowed them to predict lunar eclipses with terrifying accuracy. To them, an eclipse was a message from the heavens, a moment where the logic of math met the mystery of the gods. They gave us the 360-degree circle and the 60-minute hour. Every time you check your watch, you are speaking Babylonian. Meanwhile, across the Atlantic, in the dense jungles of Mesoamerica, the Maya were building their own cosmic architecture. Their obsession wasn't just the sun, but the great star, Venus. They tracked its movements over centuries. They tracked the Venus cycle so accurately that their calendar was off by only 2 hours every 500 years. That's more accurate than the calendar you have on your phone right now. These ancient people were masters of data. Across the globe, from Mesopotamia to the Americas, humanity was waking up to the logic of the heavens. While the Maya watched Venus, the ancient Egyptians were looking for a sign in the water. A sign written in the stars. Every year, the Nile flooded, bringing life to the desert. But knowing when was a matter of life and death. They looked to Sirius. When it rose just before the sun, the heliacal rising, the flood was exactly 1 season away. This gave them a calendar of 365 days. A celestial clock so accurate it lasted for millennia. But for the most meticulous records, we must travel east, to the imperial courts of ancient China. For thousands of years, they recorded every guest star, strange new lights that appeared and then vanished. In July 1054, they saw something impossible. A star so bright it was visible during the day for 3 whole weeks. They didn't know it, but they were witnessing the violent death of a massive sun 6,500 light-years away. Today, we look where they looked and see this, the Crab Nebula. A ghost made of star stuff. NASA's Chandra and Hubble telescopes study this nebula to understand how stars die and elements are born. Without the records of those ancient stargazers, we might have missed the date of its birth. They were the first witnesses to the violent, beautiful life cycles of the universe. From the banks of the Nile to the towers of China, humanity was realizing that the sky wasn't just out there. It was the ultimate hard drive. A record of time, location, and the destiny of empires. But the greatest revolution was yet to come. It would start with a simple stick and a shadow. 2,300 years ago, in the Great Library of Alexandria, a man performed a miracle with nothing but a stick. His name was Eratosthenes. He didn't have satellites. He had logic and the shadow of the sun. By measuring the sun's angle in 2 cities at the same time, he realized he could calculate the size of the entire world. His result? Roughly 40,000 kilometers. He was off by less than 2%. Without ever leaving his city. But the Greeks didn't stop there. Aristarchus of Samos looked at the shadow of Earth on the moon and saw a sphere. He was the first to propose that the Earth revolves around the sun, nearly 1,800 years before Copernicus. Imagine that. A world that knew the truth, but then forgot it for almost 2 millennia. Next came Hipparchus. He wanted to know exactly how far away that giant silver rock really was. He used the parallax effect, the shift in position against the stars, to triangulate the distance. He estimated it was about 30 times the diameter of the Earth. A staggering feat of pure math. Today, we use lasers to measure it to the millimeter. But Hipparchus did it with his eyes and a brain. These thinkers transformed the stars from gods into geometry, from myths into mechanics. They realized that the universe wasn't just a story, it was a problem that could be solved. From a simple stone circle to the libraries of the ancient world, humanity had built the foundations. But a long dark age was approaching. And when science woke up again, it would change everything. For over 1400 years, humanity lived in a comfortable delusion. We thought we were the center of it all. Following Ptolemy, astronomers built a universe of circles within circles to explain the erratic dance of the planets. It was a mess. A beautiful, mathematically perfect mess that didn't actually match reality. Then came Nicholas Copernicus. In 1543, he dared to suggest that we had the whole thing backward. He pulled the Earth from its pedestal and placed the Sun at the heart of the solar system. But Copernicus still loved perfect circles. And in the universe, perfect is often an illusion. To find the truth, we needed data. The most precise data ever recorded by the human eye, enter Tycho Brahe. Tycho spent decades tracking the planets with no telescope, creating a mountain of observations. After Tycho's death, his assistant, Johannes Kepler, inherited this treasure. And he obsessed over a single planet, Mars. For years, Kepler tried to fit Mars into a circle. It wouldn't work. Finally, he tried an ellipse. A flattened circle. He discovered that planets don't just move in ovals, they change speed. The closer they get to the fire, the faster they dance. Kepler's 3 laws became the first mathematical rules that governed the entire heavens. The universe had a logic we could calculate. The engine of the universe was still hidden in the shadows. We had the map, but we didn't have the fuel. That answer would require a falling apple, and a genius who would link the Earth to the stars forever. In 1665, a plague forced a young student named Isaac Newton to leave Cambridge and return to his family farm. Legend says he watched an apple fall and asked a question that changed history: if gravity pulls the apple, does it also pull the moon? Before Newton, people believed the heavens followed divine rules, completely separate from earthly physics. Newton proved them wrong. He realized the universe is a single, unified machine. He spent 2 decades developing a new kind of math, calculus, to describe the unseen threads of the universe. In 1687, he published Philosophiae Naturalis Principia Mathematica, perhaps the most important book in science. In it, he revealed the law of universal gravitation: every mass attracts every other mass. This force gets weaker with the square of the distance. Double the distance, and gravity is 4 times weaker. Newton's math was so powerful it explained everything, from the falling apple to the rising tides. He showed why planets move in ellipses, confirming Kepler's discovery with the underlying physics of force. He turned the universe into a grand, predictable machine. For the first time, we had the source code of the cosmos. Newton's laws were so accurate they allowed us to predict the return of Halley's Comet and even the existence of Neptune. We weren't just observers anymore, we were the ones who finally understood the invisible chains that hold the stars together. But Newton's clockwork universe had a tiny, nagging flaw. Mercury's orbit was off. Just a little bit. Gravity wasn't just a force. It was something much more terrifying. It was time itself bending. In 1905, a young clerk at a Swiss patent office named Albert Einstein tore down the walls of Newton's universe. He realized that time isn't a steady, universal ticking. Instead, time is personal. It stretches and shrinks. He linked space and time together into a single, flexible fabric. We call it spacetime. Imagine placing a heavy ball on a trampoline. It creates a dip that makes everything roll toward it. The sun warps the very fabric of the cosmos, and the Earth simply follows the path of least resistance. This theory made a shocking prediction: even light itself must bend when it passes a star. In 1919, Sir Arthur Eddington traveled to a remote island to prove Einstein right. He found the stars had shifted by exactly 1.75 arcseconds. Einstein was a superstar. The news hit the world like a supernova. Newton's absolute clock was broken forever. We now lived in a universe where stars could act like lenses, warping reality for all to see. A single second on Earth is not the same as a second on a massive planet like Jupiter. Time is fluid. But Einstein's equations pointed to something even darker. Places where spacetime curves so much it breaks. Einstein hated the idea of black holes. He thought his own math was lying to him. He was wrong. The foundation was set. Now, it was time to look into the abyss itself. Okay to meet the monsters? For decades, black holes remained a ghost in the equations. Most astronomers hoped they weren't real. But in the 1960s, we stopped looking with just our eyes and started listening with radio telescopes. Scientists picked up signals from the deep, quasars. Objects so bright they outshone entire galaxies. These were the engines of destruction. Spinning supermassive black holes devouring millions of stars. They were small enough to fit in our solar system, yet powerful enough to light up the entire observable universe. In 1971, we found the smoking gun for Hoden, Cygnus X-1. A massive blue star was being slowly torn apart by an invisible companion. We couldn't see the hole, but we saw its messy eating habits in X-rays. As gas falls in, it friction heats to millions of degrees, screaming in radiation before it vanishes forever. Measurement confirmed it was 15 times the mass of our Sun, too heavy to be anything but a black hole. These observations turned black holes from a math nightmare into a physical reality.
This sphere holds the memories of a dying.
They are the most efficient power plants in nature, converting mass into energy at nearly 40% efficiency. Compare that to nuclear fusion in stars, which only hits about 0.7%. Ho den lien hung k vat tiet kim. In 2019, humanity finally moved beyond shadows. We looked into the abyss, and the abyss looked back. But what if we went further? What if we dared to cross the Chandra Su Kien? Ready for a one-way trip? Crossing the event horizon isn't as violent as you'd think. At first, it feels like crossing a silent shadow. But looking back, the entire history of the cosmos is compressed into a tiny, brilliant ring of light. Then, the spaghettification begins. Gravity at your feet is vastly stronger than at your head. Inside here, the very roles of space and time are swapped. You are no longer moving through space. You are moving toward the center as inevitably as you move toward tomorrow. The center is now your future. At the very heart lies the singularity. A star's worth of mass crushed into a volume of zero. Density becomes infinite. Here, the universe as we know it simply ends. Our laws of physics shatter at the Planck scale, the smallest possible distance in nature. Einstein's gravity and quantum mechanics don't speak the same language here. They simply break. To understand the heart of the monster, we need a theory of everything. A final piece of the cosmic puzzle. The singularity is the ultimate wall of science, a place where nature hides its deepest secrets. Is it a gateway? Or is it a giant hard drive storing the information of everything that fell in? What if the 3D world we live in is just a projection from the edge of a black hole? Ready for the holographic universe? When you drop a book into a fire, the information, the story, isn't lost. It's just scrambled in the smoke. But for decades, scientists thought black holes were different. They thought information was deleted forever. This is the information paradox. If information can be destroyed, the fundamental laws of the universe break down. The holographic principle. Information isn't lost inside, it's smeared onto the 2D surface of the event horizon. Think of a credit card hologram. It's a flat 2D surface, but when light hits it, it reveals a 3D image. Jacob Bekenstein and Stephen Hawking found that a black hole's memory depends on its surface area, not its volume. Every 4 Planck areas on the horizon can store exactly 1 bit of information. A fundamental unit of reality. If a black hole can store a 3D object on a 2D surface, perhaps our entire universe is the same. Perhaps you, the stars, and the galaxies are just a 3D projection of 2D data encoded at the far edge of space. We might be living inside a cosmic projection, a grand hologram where the real us is written on the boundary. In physics, this is called the AD/CFT correspondence. A bridge between gravity and quantum math. If this hypothesis is true, it solves the paradox. Information is never lost, it's just stored at the edge. From the first stone circles to the holographic edge, we have spent millennia trying to read the universe's code. Whether we are real or just a projection, the wonder remains the same. Ready for the final act of time? As we look toward the far future, black holes are the last survivors of the universe. The final lighthouses in a dark sea. Long after the last star has burned out and galaxies have drifted into the void, these monsters will remain. For 10 to the power of 100 years, a Google years, they will be the only things left in existence. But even they are not immortal. Through Hawking radiation, they will slowly leak energy, century after century. A black hole with the mass of our Sun would take 10 to the power of 67 years to disappear completely. In their final moments, they will vanish in a brilliant burst of gamma rays, leaving behind nothing but stillness. This is the heat death of the universe, the ultimate stillness. No light, no heat, no movement. But why does this matter to us, tiny creatures on a blue dot? Because we dared to solve the puzzle. We learned that the universe has a language, and that language is mathematics. Ho Den remind us that we are the universe experiencing itself. We are the bridge to the secrets of the singularity. Our curiosity is the bridge between a simple stick in the sand and the deepest mysteries of space. As long as we keep looking up, the light of human knowledge will never truly fade. From Babylon to Einstein, from the first photo to the holographic edge, what a journey it has been. Thank you for exploring the dark with me. The cosmos is waiting for your next question.